Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Tonight we're going to have a session designed for absolute beginners, which is what we try to do the first week of every month. And we're going to use Google Colab. So I'm assuming that the people who are joining us are people who haven't seen Python before and they just want to know how to get started. So the first thing we're going to use is Google Colab, which is a free online service provided by Google to allow us to run Python programs. In fact, a thing called Jupyter Notebooks, which are a way of doing Python programs. And it's a really good way of learning, and it's really very powerful tool. Professional programmers will use Jupyter Notebooks all the time. Especially data analysts. So in the comments below this video and also on the meetup page, which is where I am, I've got a link to a Google Colab notebook that I'm sharing, and that'll have all the content that we're going to go through tonight, so you can just really step through it easily without having to do much typing at all, or there's even places in it that you can have a go at doing your typing, so you can either do that during the video or you can do it at the end and have a go yourself after watching how it's all done. So if you click on the link and takes you to colab.research.google.com, and this is a notebook that's been created. Now see, it says here changes will not be saved. That's because it's my notebook, and you won't be able to save stuff back to my notebook. But what you can do is you can make a copy of it to your drive by clicking on the copy to drive button here, or even save a copy in drive from the file menu. So click on copy to drive, and this will create a copy, and here it is. So it's got a warning about outputs not being saved, and that's just really so you don't see the answers before they happen. And I'll get rid of release notes, and this is the notebook that we're going to be looking at. Now a notebook is just a series of cells that are, can have either text, formatted text in them, or code, Python code. So this first cell is just formatted text and tells you a bit about what we're doing. We're going to show you how to use interactive Python, giving you a bit of introduction to coding and looking at branching, looping, list comprehension. Now we've got some links here. One, of course, is the link to that Google Colab notebook, a link to this video that you're currently watching, and a link to the meetup event where you could have registered if you want. You don't really need that link anymore because we're all going ahead. And we've also got a GitHub site where all our sessions I put up there. The sessions I put up there in the form of Python scripts rather than Jupyter Notebooks. So if that's how you prefer it, you can get them there. If you like the notebooks, just go to these links here on to Colab. Now because we're using Colab, you don't need to install Python on your computer, but you can install it if you like. I've got here Python 3.11.3. I just checked the latest one available is 3.12.2, which would also be quite suitable. Okay, so there are different ways to write Python. Language is the same in every case, but the users interact with the program in different ways in this case. So this is, we're using Jupyter Notebooks. Jupyter Notebooks is an extension of IPython, which stands for Interactive Python. And the reason I'm telling is because you're going to see all these different terms thrown around, and you go, oh, I want to use Jupyter Notebooks, but someone else wants to use IPython. Well, in fact, they're pretty much the same thing. Or someone else says, well, I'm just using Python. Sorry, I shouldn't have clicked. I'm just using Python. How is that different to IPython? And really, Python is a way of running scripts, but when you run a Python script, it runs right from the beginning to the end, all in one go. When you're doing interactive Python, it just runs the what's in a particular cell at a time and remembers where you're at and can just move through step by step. So IPython is definitely much better for learning because you can see exactly what's going on, and then when you get more confident, you can try writing scripts, or you can find that Jupyter Notebooks are in fact powerful enough for whatever you need. Now, this is a live video, so one of the advantages of live videos is that you can ask questions. Now, I'm going to try to look at the YouTube chat here, and I'm also going to check Slack. So we've got a Slack channel, and in there we use learning to code is what I'll be looking at tonight. So there's instructions below the video. It tells you how to get an invitation to our beginners Python Slack. If you haven't got it yet, you probably won't get it immediately, but at least you'll be ready for the next video if you do that. But try to ask questions here in the YouTube video, and if I miss them and someone else sees them, please let me know what they are in Slack, because I tend to notice the Slack ones a bit more. Alright, now the first thing I'm going to do is I'm going to share this notebook that I've got, so that you can, if I type anything in this one, you'll be able to refresh this link and see what it is I've typed without having to actually type anything yourself. So I'll send that through these, and I'll try setting it on YouTube chat, but YouTube chat does a lot of censorship, especially when I try sending URLs, so it may not get through. Alright, let's see how we go with that. But please ask questions, and they can be anything like you didn't quite catch what I said 10 minutes ago. I'm happy to go back, because this is really designed for absolute beginners, and we're just trying to give you the fundamentals of how to get started. Once you get this is really the hardest part of Python, is just getting started. Once you've got started, then you start to pick up stuff yourself. Alright, using Google Colab, so you can just type into any of these cells. These ones are here are code cells. You can see they look slightly different to the text cells, and if I hover in the middle here, I can add a new code cell or a new text cell. And so you can just do that yourself if you like. Just check that it works. So there's a new text cell, and there's a new code cell. So I'll just delete them. Also check out these menus. So we've got a help menu, so there'll be you can check out some of the things there. Tools, you can look at the keyboard shortcuts, and that's really useful as well. So I'll be using a few keyboard shortcuts tonight. So let's move on. Here's a Python code cell. Now it's got 4 lines in it. The first 3 lines start with a hash symbol, and these are comments. So you're going to see a comment doesn't do anything to Python. It's really just there for your benefit, so you can read it. So I put a few comments here just to tell you what's going on, basically saying this is a comment. And then on the 4th line, I've put a question mark. Now this is something specific to IPython rather than Python. You can just type a question mark, and it'll bring up a help screen. So if I click on the play here for running that, now the very first time you press play in a Google Colab, it takes a little bit of time. You see up here in the top right, it's Google setting up a Ubuntu computer for us with a bit of RAM and a bit of disk, so that it can run Python. And here we see a bit of help about IPython in Enhanced Interactive Python. So that's what's come up because we've typed the question mark, and it's telling you other things you can do. So you can do question mark to get this screen. You can do it as some sort of object, and a question mark to get details about that object. So that could be a function or something else like that. So anyway, there's knowing where to get help is always a useful thing when you're learning. Alright, so hopefully that worked for you as well in your Google Colab notebook. And you got there just by pressing play. Now you see here it also gives a keyboard shortcut. I could have pressed Control Enter, or in fact I will sometimes press Shift Enter and that'll jump me down to the next one. Okay, so let's look at the next cell, and we've got once again 4 lines of Python code. The first 3 lines are comments, so once again they're not going to do anything, and then we've got a very simple command. We're just going to print the number 5. So if I click on play, then we see the output from the cell comes out just below it, and there's the number 5. So by typing print 5, it displayed an output of 5. So what that means, print means print it to the screen. And this will work in Python or IPython. But because we're in IPython at the moment, we don't even need to put print. We can just put whatever we want, and it will display the value of the last line in a code cell. So if I run this one, I should just get the number 4, because I've just put a 4 there, and it gives me the answer is 4. Now if I get more than one line in a cell here, it runs them sequentially. So if I've got a line that says print 4 and then another one that says print 3, then it'll do both those lines one after the other. And so let's run it and see what we get. And you can see the first line ran and it displayed a 4, and then on a new line the next line ran and it displayed a 3 to the screen. Now how does that go if we don't have the print? If we just sort of say what's the value? Unfortunately in IPython only the data on the last line is displayed, so if you want more, you will have to use the print function even if you're using IPython. So let's just check that out to see it, and sure enough we only get the last line, which is the number 1. The number 2 doesn't do anything. Okay, so make sure you ask any questions if you don't understand any of this or what's going on, but we're trying to keep it as simple as possible so that you can get to grips with the environment rather than having to worry too much about the technical coding. Alright, so I've set a task here in the empty cell below, so this little one here, start coding. Write a Python program to count down from 5 to 0 on separate lines. Now you can have a go at this yourself, or you can just watch me do it, and so you might want to pause the video, or I'm just going to do this now. But I'm not going to do anything very difficult. We've already done similarly before. We did print 4 and 3, so let's print the number 5, and then we want 4, 3, 2, 1, 0, and let's go from this end. There we go. Now if I run this, I get the output 5, 4, 3, 2, 1, 0, and all on separate lines. So that was the task. It was very simple, but it just shows you how a Python program runs, and now you can say, you know, you've written your first Python program if you manage to do that. Now I provide a solution here, and often in my solutions I do things just slightly differently. So let's run it and see what we get. And so I've got here, I've got, rather than the numbers coming out in digits, I've got them coming out in words, and I've even put a bit of a heading on it, solution 1 counting. Alright, so to use, if I want to print out text rather than numbers, I have to put quotes around it, and I've done it showing using double quotes here. I could have actually used single quotes, would be the same, and there's a couple of other ways of doing it as well. Okay, solution 1 shows an alternative way of solving task 1. It shows when using the print with text rather than numbers, we need to surround the text with quotation marks. Text data is called a string. In Python, that is str. Alright, now there's a function in Python called type, and if I run the function, and this is what running a function is you have the function name, then you have parentheses, and inside the parentheses you pass arguments that you want to give to the function, and the function will do something with that argument. So we're going to send it a string of text, so it's ABC with quotation marks around it, and we're going to send it to the function type, and let's have a look at what it gives us back. it tells us what the type of that thing is that we've sent it, and it tells us that's a string, an str. Alright, and what string is just a way of saying text, so it's just a string of characters all together that makes some text. Similarly, we could have done it for a number like 1, 2, 3. So let's have a look at what the type of that is, and that's an int. And int is short for integer, which means a whole number. So it's got no decimal points, nothing after decimal points. They're whole numbers, and that's a mathematical definition of an integer. But Python can also work with real numbers. So here's a number 1, 2, 3 decimal point 45. What's the type of that? And Python calls them floats. And it's a floating point number, which just means that the decimal point can be anywhere in this number, and that way you can get very small numbers or you can get very large numbers. Okay, now we can also do arithmetic in Python using operators. So you've got a plus sign that does addition, a minus sign that does subtraction, an asterisk that does multiplication, a single forward slash, which does division, and that's for real numbers. But we've also got an integer division, which is double slash. So that's different to other languages that you may have come across in the past. We've got percent, which is also useful in integer division, but rather than giving you the quotient, it'll give you the remainder. And another one is double asterisk, which is if you want to raise something to the power. Alright, so here I've done an expression, 1 times 2 plus 3 times 4. So let's run that, and we see that it's calculated 1 times 2 is 2, 3 times 4 is 12, and then added those two numbers together to give us 14. So you can see that Python understands that your order of calculation, the BODMAS that you learnt in school, that you do your multiplication before your addition, and Python also respects that. If you wanted to change the order, you can use parentheses, just like in your maths at school, to change what happens first. And feel free to try it out while you're here. So like if I was to create a new code cell, I could say, well, what happens if I say 1 times 2 plus 3 times 4. So this is saying I want to do the addition first, and then I should get 20 out of that, and sure enough I do. So when we run these expressions, we can actually save the results in memory locations. And what we do, we give the memory locations a name, and the technical term for these is variables. So if I said a equals 5, that'll take the number 5 and store it in a memory location that we've made up the name of called a, and so it'll store the number 5 in a, and then I can do things with that variable such as print a. So if I run that, it'll tell me what's in memory location a, and it tells me it's 5. So a variable name has to start with a letter, can't start with a number, and you can name it anything you like. Just avoid the 35 Python keywords, which I'm not sure if I'll go tell you what they are later, but you'll certainly find out if you try to use one. It'll give you an error. It's also a good idea not to use a name of a function in Python. So, for example, don't have a variable called print, because if you put a value into a variable called print, then you'll no longer be able to call the function print, because every time you refer to it, it'll think you're meaning your variable that you've called print. And now you can see why, when we're using strings, we had to put quotes around it, and the quotes tell us that it's a literal string rather than a variable name. But because when we do numbers, we don't put quotes around it, and that's because you're not allowed to name variables like a number. All right, let's do some more arithmetic. Let's raise 2 to the power 32. That'll tell you how much memory you can address with a 32-bit operating system, and then we'll store that value in B, and then we'll take what the value of A is, which remember is 5, multiply it by the value of B, and store that in C, and then we'll print out those three numbers, A, B, and C. So there's A, which is 5, there's 2 to the power 32, which is 4 gigabytes, is the maximum amount of memory that you can address in a 32-bit operating system, and then we've got 21 billion is the value of C, is 5 times that. Okay, now programming would be very cumbersome if we had to type a line for every command we wanted to execute. So if we want to repeat commands, we will often put them in a loop. And so this is an example of a for loop. You can see for is a different color there, and that's because Google Colab has recognized it as a Python keyword, so it's colored it in that purple color for us. Also, in is another Python keyword, and it's shown it in a blue color, different to our functions, which are in this brownie color, and our variables, which are in a black color, and our strings, which are in a red color. Okay, so what we're going to do, we're going to store the value 0 into a variable called total. Then we're going to loop through all these numbers, and each time we're going to go through the loop, we're going to store a different value in the variable z. So z is going to, the first time through the loop is going to have the value 5, the second time through it's going to have the value 4, and the third time through it's going to have 3, and so on down to 0. And we're going to print out what that value of z is. So that's like before, but we didn't have to write print 6 times. We can just run this loop. Now the way Python works out where the start and finish of the looped code is it uses indentation. So you can see I've indented this code by 4 spaces. So this is quite different to other programming languages, which often use curly braces, but it makes the code look very clean, and it's a lot easier to read. Now pretty much every time you're going to indent, the line before is going to have a colon on it. So in our for loop, we're going to put a colon there to say that we're about to start a code block, and there's our code block. It's just there. That's all the indented code. Then we get to a line that's not indented, that's outside the code block. So this bit of code here, we should have this print statement should run 6 times, and this print statement should run once because it's not inside the loop. Okay, so there's a lot going on there. Definitely ask a question if you didn't understand it. I can go through that again. But let's run it and see what we get. So we've looped through 6 times, and we printed the value of z, and then we printed the value of total. And total, I've used this notation here, plus equals z. So that means take the current value of total, add whatever the current value of z is, and store the new value into total itself. And so it's come up with 15, which is correct. That's what you get for adding all these numbers. Okay, so task 2 is another task for you to have a go at. See if you can write it in this code cell, and see how you go. So rewrite the loop to show running total as it loops through all the numbers. Okay, well that is very, very similar to the code that we've already got, so I'm going to use copy and paste so I don't have to do so much typing. And when I print, I want to print 2 things. I want to print the value of z, and I also want to print the running value of the total. So if you saw before in our print command, we can just separate all the things we want to print with commas, and when we do that, it'll just print the 2 values with a space in between them, but print them on the same line. So there we go. We've got z, and then the total is 5, z of 4, total is 9. So you can see the running totals increasing as we're going through. So I've got a question here. How does the loop know where the code block ends? Is it just the indentation? And that is correct. So it because this line here is not indented, it knows that's the end of the loop. So only the indented lines are part of the loop. And if you have loops inside loops, then you can have more than one level of indentation, but you just have to be consistent with your indentation all the way through. So most people will use 4 spaces for their indentation. Some people will use tabs. Either of those will work. Some people will use 2 spaces. And I suspect actually Google Colab by default uses 2 spaces. So I've changed the setting somewhere, I can't remember where, so that it does 4 spaces, so it's like most of the stuff that you'll read on Python. But certainly with 2 spaces you will not have so much indentation, which some people like. Okay, solution 2. So this is for the same task that we've just solved. This is going to show how to use a while loop rather than a for loop. So a for loop, you have some sort of sequence here and a variable name and the word in, and it just goes through each one of the values in the sequence. When you're using a while loop, you create some sort of condition that evaluates to true, and if it's true it'll do the loop. So it'll do the loop and then it'll go back to the loop, beginning of the loop again, and reassess that condition. So it's really important when you're doing a while loop that there's something inside that loop that is going to change what the value of that condition is that it's checking. In this case the condition is based on z, the value of the variable z, so we've got to have something in our loop that changes the value of z, and sure enough we've got a line here that will reduce the value of z by 1, and then when it comes back up here it'll check to see whether that z is greater than or equal to 0. Alright, so let's run that. And in our print statement we've been a little bit more fancy. We've said what the number is, which is 5, and what the running total is, which is 5, 9, 12, 14, 15, 15. Okay, write a loop which counts up from 1 to 5 and displays the factorial of each number as it goes. So if you know what the formula for a factorial is, it's factorial of n equals 1 times 2 times 3 all the way up to n. I remember when we were at school we used to set our calculators to calculate the value of factorial 69 because it used to take forever with our slow calculators, and that was the largest number that our calculators could display, the largest factorial number it could display. So factorial 70 would fail. But anyway, let's start here. So we're going to start off with a value 1. Then we're going to loop up from 1 to 5. 1, 2, 3, 4, 5. Then we're going to multiply z by our factorial. And remember how we do that? We just say take the current value of factorial, multiply it by whatever z is, and store the new value in factorial. And we've got to just display the factorial for each number as it goes. So we just have to print those two things. Okay, let's run that. And so we go factorial of 1 is 1, factorial of 2 is 2, factorial of 3 is 6, factorial of 4 is 24, and the factorial of 5 is 120. Okay, so this works all right. It's going to get pretty tedious if we want to do the value of factorial 20. We'd write 1, 2, 3, 4, 5, 6, 7, 8, 9 all the way up to 20. So fortunately there's a function called range, and range will return all the numbers up to but not including the last number. So here we go, we've got range of 1, 20. So let's run this code and see what the values of z are as it runs. So you can see z starts at 1 the first time through, the second time through it's 2, the third time through it's 3, and it goes all the way up to 19. So you can see it's gone all the way up to, but not including the number 20. So we can see now the factorial of 19 is this very large number. If range also works, is the first number is optional, it will default to 0, but if you put the first number in, then that's where it will start from. If we put 0 in, our code wouldn't work because we just have 0, 0, 0, 0, 0 all the way up. So we need to start at 1, and then we're going to stop at 20. Okay, task 4, display the first 20 numbers in the Fibonacci sequence. So Fibonacci is defined by, if you've got the first number and the second number, then the first number is always 1, the second number is always 1, and then the nth number is always the n minus 1 number plus the n minus 2 number. So that means that f3 is going to be f2 plus f1. f4 is f3 plus f2. Okay, so this is what the sequence will look like. 1, 1, 2, 3, 5, 8, 13. Okay, so we want to write some code that will do that. So let's start. We can do f1 equals 1, f2 equals 1, and we want to do 20 numbers. Okay, so our value of n will go, let's just call it n in range 20, so that'll go from 0 to 19, and we're just using it as a counter, so that's fine. Okay, so fn is going to be equal to fn minus 1, which we'll call it 2, f2 plus f1. Okay, and now we can print. Let's just print all three numbers, f1, f2, fn. Okay. Now we have to change what's in f1 and f2 based on what was previously there. So we can do what's in f1 is going to be what was in f2, and what's now in f2 is going to be what's currently in fn. Okay, let's run that. So we got 1, 1, 2, 1, 2, 3, 2, 3, 5, 3, 5, 8. So you can see each of these numbers is the sum of the previous two. And in fact, our sequence, which is what we're after, the first 20 numbers, is this first number all the way down. So it's 1, 1, 2, 3, 5, 8, 13, 21, 34, all the way up to 6,765. Now we had to we needed 3 variables to do this because at any one time we had 3 different values that needed to be stored. But Python's got a thing that that you can do, which once again I haven't seen this in other languages, but it's you can have multiple assignment statements on one line. So for example, rather than having f1 equals 1 and f2 equals 1, I can say f1 comma f2 equals 1 comma 1. Alright, then I can have my loop, and I'm just going to do 18 times because in fact in my example above I've actually calculated 2 more numbers in the Fibonacci sequence than I needed to. I'll print out what f1 is, and then I'll replace f1 and f2 with these new values, and you can see that I'm putting f2 into f1 and I'm putting f1 plus f2 into f2, so it just saves me a variable, and this can be pretty useful times. The Fibonacci sequence is a one where they like to is a simple example where you can use this sort of facility, so it is quite common to see this example displaying how you can use multiple assignment statements on one line and save yourself a variable. The other thing I've done here to save myself another variable is I've got a variable name called underscore, and that's just really saying, well, I've got a variable, it's got to store this number in it, but we never use it, so I'll just call it underscore, and that just tells me don't be using this number, so I'm not going to waste my namespace giving it something. Okay, let's run it and see. And oh yes, I've done a special form of the print command where I've printed the value, and then I've added an extra argument into the print function saying I want the end character to be a space rather than a new line. So every time I run that print, it stays on the same line, and all the way up until I run this print here, which will print these last two values, and then it'll print a new line. So I've thrown in quite a few new things there in that solution. So let me know if there's any of those I went over too quickly, and I can repeat it. All right, now count down in steps of 2.25 from 10.5 to -3 inclusive. Okay, so for this one I would I don't know how many times I'm going through, so maybe I won't use a for loop. I'll use a while loop. So I've got a start value. Well, I'll just have my variable x will be the start value, 10.5, and I'll keep going until while x is greater than or equal to -3. Then I'm going to print x, and then I'm going to subtract 2.25 from x. And I'm going to need to do one more print x at the end, because oh no, that'll be fine, because x will be -3 the last time we go through here, but I don't need to print it again, even though it won't be 3 when I finished. Okay, so 10.5, 8.25, 6, 3.75, 1.5. Well, that seems to do what the task asks for. So let's see another way of doing it in solution 5. So solution 5 does want to use the for command, and it wants to use range, but range can only work with integers. And actually that's what I should do, is I'll show what will happen if I try to use the range command. So if I could say x in range, and I'm going to start at 10.5, that's right, and then the next thing is going to be the stop value, which is -3, although I want up to but not including, so let's go -5.5, and then I do the step value, which is going down, so it's -2.25. Alright, now I get an error, and the reason I get the error is because range doesn't work with floating point numbers. So that's what we've got in this situation. So what's the solution? The solution is convert everything to integers. So we can work out the lowest common denominator. So 10.5 is the same as 21/2. Our final value is -3, and our step is -2.25, and so it's got a denominator of 4, is the same as -9/4. So the lowest denominator is 4, lowest common denominator. So let's just convert all of these things to integers, and then when we print them out, we'll divide by the lowest common denominator. So this way we'll be able to use 4. So that worked. We've got 10.5, 8.25 all the way down to -3. I'm showing you a fancy form of the print function here. This is called an F string, and that allows us to do a bit of formatting as well. So we do it inside a string. So it's a text string, and we can put extra text in there if we want. So I could say, x equals, let's run that, x equals, and then I'm formatting it. I'm saying I want the number to be displayed in 7 characters with 2 decimal places as a floating point number, and so it's lined them all up. The decimal place is nicely lined up, even on the negative numbers. So that's a really nice way of formatting. Alright, so that worked when we were going down in steps of 2.25. Let's try going down in steps of 0.1 and see what happens. So 1.0, 0.9, 0.8, 0.7, that doesn't look right. So what's going on here? And the problem with this is that Python stores its floating point numbers in binary, but you can't represent the number 0.1 in exact binary. You can represent 2.25 in exact binary, but you can't represent 0.1. So every time we subtract this number, we're not subtracting 0.1, we're subtracting a number that's slightly less than 0.1, and that error accumulates and accumulates. So it wasn't obvious the first 2 times, but the third time there was enough error that it actually displayed a different number when we went to display it, and that error got bigger and bigger as we got all the way down to 0, and finally this number should be 0, but in fact it's 1.38 blah 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 by 10 to the minus 16. Right, so what can we do about that? And this is one of the reasons why they don't like using floating point numbers in range, because this sort of effect can happen. But anyway, if we use integers, and this time we use the lowest common denominator of 10, we can see that it prints out really nicely, because the integers, there's no error when you convert an integer into binary, and then we divide by 10 there. There's a bit of error there, but it's not accumulating. It's because these are going down as integers, so the error doesn't accumulate. Alright, now most of the time you're not going to notice this sort of problem, but I'm just telling you now just to be aware of it, especially when you're doing something like that where you've got a floating point number and you're doing something that accumulates it, so the error is just building up. Alright, so let's move on to something else. We're going to look at the list data type. So it's an ordered collection of data values of any type. So, and you write it by using square brackets. So inside the square brackets I've just put a bunch of integers, and I just separated them by commas. I've put them in a list and I can print them. There we go, there's my list. And I can refer to different numbers in there. Now you can create a list using a loop. So we start off with an empty list, and then I'll go through a loop 30 times, and each time I'm going to append a value of 2 times x to my list, and then I'll print out what my list looks like. Okay, there's my list. And now I can do things with that. And I'm not sure if we'll get on to doing much with lists today, but I'm just showing you how to create them. So the task is create a list of numbers from 20 to 0, stepping down by 4 each time. Okay, so we create an empty list. So I'm not going to call it list, because that's that's actually a name of a function that we would use when we want to create lists. So I'm going to use the square brackets, and I'm just going to call it lst. Maybe I could call it lyst, just so I don't call it list. Alright, and now we want to go from 20 to 0, stepping down by 4 each time. for x in range 20, comma, and we're going to go a bit further than 0 because it'll, if we put 0 there, it'll stop before it gets there, and we'll go down 4 at a time. So I have to put -4 to make sure it's going down and not up, and let's append the value x and then print it. There we go, 20, 16, 12, 8, 4, 0. And so that worked. Okay, and now here's the solution. You can actually just use a list constructor because it's such a common thing that you need to do, and you can just put the range straight into the constructor. So list with parentheses is something that makes a list, and then we just put the range in there, and we store it in list 6. So that's a valid name because it's not list, and we get the same thing. Okay, so this will this format of using the type name as a constructor or a function that returns that a value of that type can be used for a lot of the types. So for example, if I've had what's a floating point number from the integer 4, so I can convert types by using float on an integer, and that'll give me 4.0. Or I can say what's integer for 4.2, and that just converts it to an integer 4. I could say give me a string, and you can see it's put the text in there, the numbers that make up the text, and puts quotation marks around it. Alright, task 7, create a list of the square numbers from 0 squared to 10 squared. Alright, now I can't use this trick then, because this is only for a linearly increasing sequence or decreasing, but now I want to do square numbers. So how do I do that? Well, I've got to go back to a for loop. So we'll go from 0 to 10. We better create our list to start with. I'll call it list 7. 4. And there I can put in x squared and then print my list 7. So there's my list, 0, 1, 4, 9, so it's all the squares going up to 100. Let's have a look at the solution. So what have they done here? This is such a common set of lines that people would do, these 3 lines, something equals an empty list, a for loop, and then keep appending values into the list, that they created a syntax in Python called list comprehension. So that's what we're putting in the list. So in this case there's our for loop, and you put all that inside the square brackets and you get the same thing. Alright, and you can do it, let's have a go at this task, task 8, create a list of tuples. So tuples are very much like lists. They're like a read-only version of a list, so you can create a tuple, but then you can't change anything in the tuple once you've created it. And tuples are designated by parentheses rather than square brackets of the list. And we're going to try to use list comprehension to do it. So in fact I'll just jump straight to the answer, because there was nothing special that I was going to do apart from this. So for I in range 11, and there's my tuple. So let's run the answer code, and so you can see I've got all these tuples in here, 0, 0, 1, 1, 2, 4. So each tuple is a pair showing the index and the square of the index. Alright, now this is, remember, a very introduction to, it's a very basic introduction to Python, but I just want to show you a few of the different things so that you recognize them when you see them. And we've done for loops and while loops, and now another structure is if then else, or if, else if, and else. So if means check if something is true, and we see here we've got a colon, which means the next line is going to be indented, and then we have a code block. We could have one we just got the one line, and we're going to say if I modulo 3 equals 0, and remember this is the remainder from dividing by 3, then we can say that I is divisible by 3. And then elif is the same as else if. Else if I modulo 3 equals 1, then I is 1 more than a multiple of 3. And else, which is all the other cases, then I is 1 less than a multiple of 3. So let's run that, and you can see how we've just nested indentation over on indentation. So 0 is divisible by 3, 1 is 1 more than a multiple of 3, 2 is 1 less, 3 is divisible by 3, and so on. Okay, so create a list of numbers from 20 to 0, stepping down by 4 each time, including numbers divisible by 3. Well, I thought I had list comprehension under control, but now it's gone and asked me for something that I don't know how to do. So I'm going to have to go back to my for loop. So let's try this. I'll go list. I'll go back to my old naming. OAST, create an empty list, do a for loop, I in range, and I'm going to go from 20 to -1, stepping -1, so that it gets to 0, and then I can add that to the list. Alright, actually we've got a question which we might just jump to while we're in the middle of this. Please remind me what the significance of the F is in the print statement F there. Yes. Oh, well, there's actually 2 F's in that line, so I'll tell you what both of them are. So the first one, the first F, which is outside the double quotes, is telling you what sort of string it is, and it's an F string. And what an F string is it means when Python sees F strings, it looks inside the strings for curly braces. So anything outside the curly braces is just considered as a normal string. Anything inside a curly brace is considered as an expression, and so it will evaluate the expression. And so in the expression you've got 2 parts. You've got everything that's left of the colon, which is what has to be evaluated, in this case x divided by LCD, and then what's right of the colon is the format that we want it to show. So in this case it was 7 characters wide with 2 decimal places, and it's a floating point number is how we're displaying it. So yeah, I could put in, you saw I put in extra text in there. I put a, let's go back to have a look at it. These F strings were only introduced in like Python 3.6, but they've been so popular that all other formatting that people used to do in has really been where did I do it? Here we go. All other formatting methods have really been replaced by F strings. So I only ever teach F string formatting these days because no one really needs to know the others. This is such a powerful way of doing it. So you see how with the F there, these curly braces are in green, and that means it's a different color, so Google's going to, the Python in Google is going to actually treat it differently. Now if I take the F away, you see how it all goes red. So that's what it would print if I didn't have the F there. So if I just run that, I'll just get that. So by putting the F there, it's just telling Python it's an F string, look for curly braces, and treat them and look for expressions that are in them. Now, of course, sometimes you might want to actually print a curly brace, and so in that case you just put two of them. And so you see I've got a double left curly brace and a double right curly brace, and it's just printed it out as a single curly brace. So that's how you print curly braces in F strings, but otherwise you just put in, and you can put lots of expressions in there. You can you know, I want to evaluate that expression, and I want to evaluate this one. This one I haven't put any formatting on it, so there's no colon in there. There's a couple of other sorts of strings that you'll come across which will have letters out the front. One's called a raw string with an R out the front, and that just means that's useful if you need to display backslash characters, because otherwise backslash character looks like an escape. But if you make it a raw string, then it'll just treat backslash characters just like normal text. There's also Unicode, which is the default. So if you in Python 3, if you don't do anything, it'll be the same as if you've put a U there. And the reason that is so you can write code that works in Python 2 and Python 3, because in Python 2 the default was B, and so that was a bytes string rather than a Unicode string. But in here we'll just use F for format string. That's a good question. All right, so here we're doing down to 0, stepping down by 4 each time, and excluding numbers visible by 3. Okay, so we'll check if I %3 does not equal 0, then we can append. Yeah, so 2016, 12 got excluded, 8, 4, and 0 got excluded. Okay, let's have a look at the solution. So there is actually a way of doing this in list comprehension. We put the value we want stored, we have our for loop, and then we can have a conditional if statement, all in the list comprehension. So that's pretty much as complicated as list comprehensions can get. Well, let's run that and check we get the same answer. Yeah, we do. All right. So we can, these variables that we've used, we've seen how we can store tuples, we can store lists, we can store integers, floats, strings, but we can even store range objects. So, you know, this range function that we created, a range object that was used in the for loop or in our list comprehensions, we can actually store that into a variable. So I store it in R, then I say print R, and it prints range 3, 14, 4, which is really just telling you what it's got. But you can also, now that it's in R, you can create a list from R, and that will evaluate it out and create a list from it. Okay, task 10. Now this is getting pretty complicated, but I like to just throw it because sometimes I get more experienced people to these beginner sessions, so I thought I'd throw in a more complicated one just to keep them interested. Rewrite the following code using nested loops. So we've got a range function for, and what am I going to do? Alright, so it's printing out, well, let's just run it and see what it prints out. So it prints out range 4 is the value 0, 1, 2, 3. Range 2 to 5 is 2, 3, 4. And so this is just giving you an idea of what's how range works. You can see going from 12 to 3, but the default step is +1. The range is empty because it will never get to 3, because it would try to step up from 12 rather than down to with a step of -1. So that's the correct way of doing it. That one doesn't work. Okay, and we've just used print statements. We're printing each value. We've stored the range in a variable. We're going through the range, printing on the same line, and then we do a print at the end to jump down to the next line. Okay, so now think about how you might do that. But here's a solution using a loop to display the different forms of range. So all of these lists I've created here are the arguments that I was passing through to the range function, and I've just stored them in a list. And I'll put the whole lot in a tuple. I could have done tuples of tuples. I could have done lists of lists. I've chosen tuples of lists. Doesn't really make it much difference at this stage. And I'm going to go through that. So each time it goes through here, this loop, the first time it'll come through, the range arguments will be the list 4. The second time through, the range arguments will be 2 and 5. The third time through, the range arguments will be 3, 14, and 4. And then I take that list of arguments and I put them into the range function. And I put this asterisk in front of the variable range args. And what that means is explode the list in place and place each of the values that it gets into the ordered arguments of range. So for example, if it was 3, 14, 4, it'll put this will be the same as saying range 3, 14, 4. And so you might see this asterisk in code that you're looking at, and that's what it means. It explodes the list in place. It's more advanced, but it's nice to see a couple of these things, because the first time I saw that, I had no idea what an asterisk out the front of an argument, a variable name would do. Then I'm going to print out R, which is, remember, a range object, and then I'm going to loop through it, print out all the values in it, and then create a new line. So this is really just test code to see how range works. It looks slightly different because even though I've only passed a 4 in on the first one, when you say print R, it prints range 0, 4. But that's okay, we understand what that is, but all the values are the same. And I've just said I put in a :20 there to make it line up a bit more neatly. And there we go. So that's the end of the session. I hope you learned something from that, and I hope you have fun doing the puzzles, the tasks that are in this, and go through and have a go yourself without looking at the solutions. And really, that's the way you learn, is by doing this stuff. And that's why Google Colab is such a fantastic way of learning Python, because you can do these things. All right, I will. That's it for this week. Next week, Arun will be doing the session online, and the week after that is going to be in town at Brisbane Business Hub, and that'll be our last 2 sessions in Brisbane Business Hub. Will be the February and March ones, because Brisbane Business Hub are moving, and we haven't yet worked out. Well, we've got a new venue we're going to try in April, but if anyone knows of a good venue, like, we're still looking around to see what would be a good ones to use. So until next time.